This lesson is on solving word problems using systems of linear equations. For some word problems, there are two unknown quantities and two conditions relating to these quantities. To solve such problems using algebra, define a pair of variables, set up a system of equations, and then solve the system to answer the question. Be sure to completely define the variables. For example, do not state x equals taco, state x equals number of tacos, or x equals cost of a taco, or x equals weight of a taco, whatever it is you're trying to determine. Also, state your answer in a complete sentence. For example, at the end of the 2000-2001 football season, 31 Super Bowl games have been played with the current two football leagues, the American Football Conference, AFC, and the National Football Conference, NFC. The NFC won 5 more games than the AFC. Determine the total number of wins by each conference. So our variables will be what we're looking for, how many wins by each conference. So let x equal number of games won by NFC, and y equal number of games won by AFC. There's a total of 31 games, so x plus y equals 31. The NFC won 5 games more than AFC, so the number of games they won, x, is 5 more than the number of games won by the AFC, y, so x equals y plus 5. Since x is already solved for in terms of y in the second equation, the method of substitution will work well for this system. We substitute y plus 5 for x in the first equation and solve for y. So first equation is x plus y equals 31. Using y plus 5 for x gives us y plus 5 plus y equals 31. Collecting like terms, 2y plus 5 equals 31. Subtracting 5 from each side gives us 2y equals 26. And dividing each side of the equation by 2 gives us y equals 13. We also need to find the other variable x, so we can substitute y equals 13 into the second equation. This gives x is y plus 5, or 13 plus 5, or 18. So x equals 18. To finish the problem, we need to answer the original question in the form of a sentence. So the NFC won 18 games, and the AFC won 13 games. Giselle works as a carpenter and as a blacksmith. She earns $20 per hour as a carpenter and $25 per hour as a blacksmith. Last week, Giselle worked both jobs for a total of 30 hours and earned a total of $690. How long did Giselle work as a carpenter last week, and how long did she work as a blacksmith? So the first step is to define our variables, which are what we're trying to find. So we let x equal the number of hours Giselle worked as a carpenter last week, and y equals the number of hours Giselle worked as a blacksmith last week. Since she worked a total of 30 hours, x plus y equals 30. Since she earned a total of $690, x hours at $20 an hour as a carpenter would be 20x, and y hours at $25 an hour as a blacksmith would be 25y. So 20x plus 25y equals 690. We will use the method of elimination to solve this system. To eliminate x, we want to cancel out the 20x with the negative 20x, so we can do this by multiplying the first equation by a negative 20. So the first equation multiplied by negative 20 gives us negative 20x minus 20y equals negative 600. Second equation was 20x plus 25y equals 690. Adding the two equations, the negative 20x and the 20x cancel. X is eliminated, so we're left with 5y equals 90. Dividing both sides of the equation by 5 gives us y equals 90 divided by 5, or 18. To find x, we substitute y equals 18 into the first equation. This gives us x plus 18 equals 30. Subtracting 18 gives us x equals 12. So last week, Giselle worked 12 hours as a carpenter and 18 hours as a blacksmith. In this example, my younger cousins worked part-time jobs over the summer to save money for a car. The job paid different rates for working weekdays and weekends. During the first week, one cousin worked 22 hours during the week and 1 hour on the weekend, earning $232. Her sister earned $270 by working 15 hours during the week and 10 hours on the weekend. What was the hourly pay rate for working weekdays and weekends? So our variables will be what we're trying to find out. X is the hourly rate for weekdays, and y is the hourly rate for weekends. The first cousin worked 22 hours on weekdays and 1 hour on the weekend, so her total pay was 22x plus y, which is 232. The second cousin worked 15 hours during the week and 10 hours on the weekend, so her total pay was 15x plus 10y, which is equal to 270. This gives us our system of equations. To eliminate y, we would want to add a negative 10y to the 10y we have in the second equation. We can do this by multiplying the first equation by negative 10, which gives us negative 220x minus 10y equals negative 2320. Adding this to the second equation, 15x plus 10y equals 270, gives us the equation negative 205x equals negative 2050. Dividing both sides of this equation by negative 205, this is x equals 10. To find y, we can substitute x equals 10 in the first equation. So 22 times 10 plus y equals 232. So 220 plus y equals 232. Subtracting 220 from each side gives us y equals 12. So the hourly rate is $10 for weekdays and $12 for weekends. In this last example, the cost of admission to a concert for a group of 2 adults and 3 children was $58. The cost of admission for a group of 3 adults and 5 children was $92. What are the costs of an adult ticket and a children's ticket? So the variables are what we're looking for. Let x equal the cost of an adult ticket and y equal the cost of a children's ticket. The first group had 2 adults and 3 children, so their total cost would be 2x plus 3y, which is 58. The second group had 3 adults and 5 children, so their total cost would be 3x plus 5y, which is equal to 92. So this gives us our system of equations. If we wish to eliminate x, 2 is not a multiple of 3 and 3 is not a multiple of 2, so we need to find a common multiple. The least common multiple of 2 and 3 is 6. So we can get 6x by multiplying the first equation by 3, and negative 6x by multiplying the second equation by negative 2. This gives us the following equations: 6x plus 9y equals 174, and negative 6x minus 10y equals a negative 184. Adding these two equations, the 6x and negative 6x will cancel, x will be eliminated, and we're left with negative y equals negative 10, so dividing by negative 1 gives us y equals 10. To find x, we can substitute this into the first equation, so 2x plus 3 times 10 equals 58, or 2x plus 30 equals 58, subtracting 30 gives us 2x equals 28, and dividing by 2 gives us x is 28 divided by 2, or 14. So adult tickets cost $14, and children's tickets cost $10. In the activity that accompanies this lesson, you'll get more practice with setting up word problems and solving them using systems of equations.